Okay, so we are dealing with exact trigonometric values. This is chapter 6.2 at Excel Pure Maths 2. I hope you're with me. Okay, so when we are doing this exact trigonometric values, we should know that from where these values are coming. Do you know how to prepare an equilateral triangle?
That means that all of the angles are the same.
Yeah. So if I have an equilateral triangle, I would say I have an equilateral triangle A, B, and C. All the angles are the same. That means A is also 60 degree.
Yeah, B is also 60
B
degrees and
is
C is
also
also 60
60
degrees.
degree and C is also 60 degree. Okay. If I break this into two equal parts by a perpendicular bisector, when I say perpendicular bisector, that means it is dividing it into exact two equal parts. So this part is exactly half of this part.
Yeah, so
So
our angle A
this is going
will
to
become
become
30
30
degrees.
degree. This is going to become 60 degree and this is going to become 90 degree.
Yeah,
I hope you're with me. So
yes.
we have that property which is called the 30, 60, 90 triangle. Which property do we have? 1 minute. The properties of a 30, 60, 90 triangle is that the side that is opposite to 30 will be 1. The side that is opposite to 90 is going to be 2. And the side that is opposite to 60 is going to be root 3. This is a property of your 30, 60, 90 triangle. Are you with me?
Yes.
Okay, fine. Now, if I want to find my sine, my cos, and my tan for a 30, 60, 90 triangle, I can find sine, cos, and tan for which values?
What do you mean by which values?
It's a 30, 60, 90 triangle, right?
Yeah.
Since it is a 30, 60, 90 triangle, I can find my sine, cos, and tan for which values? I can find my sine, cos, and tan for 30 degree, for 60 degree,
And 90 degrees.
and for 90 degrees. Are you with me?
Yes.
Then you also remember this property of what? You remember this property?
Yes, sine is opposite divided by
So the
hypotenuse.
sine is opposite over the hypotenuse.
Yeah.
Cos is adjacent over
Cos
the
is adjacent
hypotenuse.
divided by hypotenuse.
And tan
And
is opposite over the adjacent.
yeah.
Okay. Now let's see. I'm just reviewing it again. My equilateral triangle. Whenever you have to find using something for 30, 60, and 90, you make an equilateral triangle, divide it into half, and you make it a 30, 60, 90 triangle. Okay? So side opposite to 30 would be 1, side opposite to 90 would be 2, and side opposite to 60 would be root 3. You can also use Pythagoras if you want, but we do it like this. I hope you're with me.
Yeah.
Can you give me the value of sine 30? Opposite over the hypotenuse.
Yeah.
This is the hypotenuse under any circumstances. So sine
Yeah.
30 is half.
1 by 2.
Okay. Cos 30
Cos 30, which would be root 3 divided by 2.
adjacent over hypotenuse. So this is
Yeah.
adjacent over hypotenuse. So it is root 3 divided by 2. Okay. And tan 30.
1 divided by root 3.
1 by root 3. Okay, let's go for 60. Sine 60.
Sine 60. So it's gonna be root 3 divided by 2.
Cos 60.
Cos 60 is gonna be 1 by 2.
And tan 60.
Tan 60 would be root 3 divided by 1. It should be just root 3.
Now sine 90.
So it's gonna be 2 divided by, no,
2 divided by 2. The opposite and the hypotenuse
yeah,
is the same. Yeah.
okay, and then
Cos 90.
it would be 1 divided by 2
And tan 90.
would be 2 divided by 2, should be 1.
Opposite over adjacent.
Yeah.
Okay.
Hmm.
Can you tell me tan 90? Is it possible?
What?
Is it possible to have a tan 90 of 2?
Tan 90 of 2. No.
Okay. Okay. So we are just keeping this in doubt. Are you with me?
Yeah.
Okay. So when you have a 30, 60, and 90 triangle, you will always draw an equilateral triangle. Okay. To find the values of sine 30, that means sine, cos, and tan 30, 60, and 90. Now, what are you left with? Which degree you are left with is the 45 degree. Okay, so a 45 degree triangle, for a 45 degree of sine 45, cos 45, and tan 45, you make an isosceles triangle. Which triangle you will make? Isosceles
Isosceles triangle.
right angled triangle. If you make an isosceles right angled triangle, the triangle would look something like this. Okay, if this is 90, the base angles of isosceles triangle are the same.
Yeah, so there'd be 45 and 45.
So isosceles right angle triangle also represents a 45, 45, 90 triangle. Okay. So keep this in mind and find for me sine 45, cos 45, and tan 45. When you have an isosceles right angle triangle and you're trying to look and find the trig values, you're going to label this as 1 and 1. Okay. If it's A, B, and C, you will find the hypotenuse. How will you find the hypotenuse? Your AC would be
My AC would be root 3.
root of 1 square plus 1 square.
Yeah, root of 1 square plus 1 square would be,
It's going to be root 2.
yeah.
Okay. And now find for me sine 45, cos 45, and tan 45. I'll wait for you. So your sine 45, this would be opposite over hypotenuse, adjacent over hypotenuse, and this would be what?
Opposite by adjacent.
Opposite by adjacent. So your
Hmm.
sine 45 is
1 divided by root 2,
hmm,
and then again 1 divided by root 2, and then 1 divided by 1, which would be 1.
it would be 1. Now if I have to do this using a triangle, okay, 30, what are the values that you would consider is 30, 45, 60, and 90. These values you should definitely know. Okay, which values you should definitely know? Tell me.
30, 45, 90, and 60.
60 and 90. Tell me 30, 60, 90 you will get from which triangle?
Equilateral triangle.
Equilateral triangle. Opposite to 30 you will put 1. Opposite to 90 you will put 2. Okay.
Yeah.
If you don't understand, then you will do like this: 1, 2, and root 3.
Hmm.
And for 45, you will go to where? I saw
Isosceles
you.
right angle triangle.
Now, for your exact trig values, I want you to prepare along with me the values that you should know it by heart. And if you don't know, you should know how to calculate. It would be for your 35, 45, 60, and 90. Okay. And 0, we will find. Are you with me?
Yeah.
We are finding the exact trig values of sine, cos, and tan. Are you with me?
Yeah.
Okay, fine. So sine 30, divide by 2, divide by 2, divide by 2. Okay. Cos, again divide by 2, divide by 2, and divide by 2. Now this is the way to memorize it. For sine 30, 45, and 60, you're going to write 1, root 2, root 3, and this would be 1 and 0. What did we do? Come on, tell me for sine.
Okay, for sine, first of all, sine 0 would be always 0, but then
This would be
from
0 and 1.
30 to 60, 30, 45, 60 would be divided by 2. Okay. And
1,
for sine,
root
it would
2,
be
root 3.
1, root 2, and root 3.
Okay. Cos would go opposite, just the opposite of sine. Just the opposite of sine. That means if this is starting with 1, so this will start with 1. And you write
Okay.
everything the other way around. Okay?
Yeah.
Okay? And then for tan, 0 by 1 is 0. Tan would be sine by cos. Okay? This would be 1 by root 3. This would be 1. This would be root 3. And 1 by 0 is undefined. You either do it this way or you do it this way, you're going to get the same answers. Now I'm going to crop and I'll show you. See, tan 90, I had put a question mark. Did you see that?
Yeah.
Because sine, cos, and tan always would range from 0 to 1. So because this is 1 divided by 0, this is undefined. 30, 60, 90, half, root 3 by 2, 1. This we got from 45 degree. Now over here. We have got 1 by root 2, but over here the value is root 2 by 2. 1 by root 2 or root 2 by 2 means the same thing.
Okay.
Okay? Can you tell me why? If I do not want the root in the denominator, I would rationalize. Yeah?
Yeah, you will rationalize.
So this will become root 2 by 2. Are you with me?
Yeah.
Okay, fine. Now I want you to draw the table 30, 60, 90, and the 45, 45, 90 yourself and tell me if you're clear with it. And give me that table by heart. I will see, I'll observe. Now fill the way that I am telling you. You have sine, cos, and tan, 0, 30, 45, 60, and 90. Sine 0 would be 0 for which ones?
For sine and tan.
0 degree. You will have values 0 and 0 for which ones, okay? And cos 0 would be,
Cos 0 would be 1.
okay. Cos 90 would be,
0.
put. So the above and bottom, sine and tan, 1 and
Undefined.
can you fill in the 45 degree for all three? Can you fill the 60 for sine and 30 for sine? Balancing, fill everything.
What?
Fill the remaining boxes.